Okay, I'm just going to do 14.1 and 14.2 translations, and I'm going to talk about mappings and isometries, and basically what we're going to have here is that, well, we're going to talk about a few different terms. If I take this circle and move it up there, that's a mapping. We can also call this the pre-image. A lot of this is just vocabulary. And that up there is the image. We kept all the shapes the same. We just moved everything from there up to there. That's also a mapping. It's a mapping because when we in a mapping, you don't have to keep everything the same. Like I could have done a mapping by going from this to this, but I would have kept everything, the ratios all would have been the same, and I would have gone from here to here, and here to here, and here to here, and I would have had some kind of rule that would take me from these points to these points. So that would be a mapping. And in fact, that's a one-to-one mapping, because this point would go to this point would go to this point would go to this point. Every point would go to one other point. Again, this is all just definition kind of stuff. Now, if we want to have an isometry, as you and I talked about today, this is an isometry because the distances stayed the same as they did here. This is not an isometry. So that's an isometry. And that is not an isometry. All right. An isometry can be called a congruence mapping, because I mapped everything down here up to points up here, and they were congruent. And so I mapped stuff congruently from this space to this space. So that's 14.1. Now we'll do 14.2. And we're going to talk about reflections. And if I take some line like this, or a segment or whatever, and I want to reflect it about the y-axis, what I'm doing is I'm moving this point straight to the y-axis and moving it an equal amount on the other side of the y-axis. And when I do that for all of those points, I get this, where, essentially you could say your line of symmetry is this guy. That every point here I go bam, and I get to a point over here. Every point here I go bam, and I get to a point there. And so this is an isometry. Again, this is all just definition. That's an isometry because this distance is the same as this distance. I think that's it for 1 and 2. Let's see if I can see some little problems. Well, so there's some example problems saying, you know, if I want to reflect this about the x-axis, then I've got to do this. Because every point, a point here, if I'm reflecting it about the x-axis, I got to go straight at the x-axis and go an equal amount down there, and I get to that point. This point, I go straight down, and straight down again, I get to this point. So this is a reflection about the x-axis. And if I want to do that, I can do other reflections. I can, what is that? I can do a reflection. I'm going to do a reflection of this. About the line y equals x. And that means I'm taking this point, I'm slamming it straight into there, and I'm slamming it an equal amount on the other side of the x-axis. And that's getting me somewhere over there. I'm taking this point, I'm slamming it into there, I'm slamming it an equal amount there, and that's taking me somewhere like that. And I'm taking this point, slamming it there, slamming it again, an equal amount there, and I don't think I did this very well, but that should take me to something like that. So, yeah, roughly speaking, I think that's right. And, you know, hey, Monica, I think I just did one. I think it got lost. All right, I'm going to do a quick thing on what they're calling, a lot of this is vocabulary. They're talking about things like this, circle there at the top of that hemisphere, and they're saying if you move it up here, keeping everything the same, which I didn't do a very good job of doing, then you have a pre-image down here, and you moved it up, and that becomes an image. It's also a mapping. Anytime this would also be a mapping. I changed the size of everything, but I kept, this point going to this point going to this point, all the way through, and that makes it a mapping. This is also a one-to-one mapping, because every point down here goes to one point up there. This one here if those sizes were all the same, would be an isometry, because it kept the distances the same. Whereas this here would not be an isometry because it didn't keep the distances the same. We could also call an isometry congruence mapping. Because not only are we mapping stuff just like we did here, but we're keeping the distances the same. So they're congruent. And then we're going to talk about reflections. And that's 14.2. And when we do reflections, we do things like take a point over here and move it over there. That's a reflection about the y-axis. If I took a point here and moved it down there, that's a reflection about the x-axis. Because what did I do? I slammed straight down there, and I slammed the same distance to get to this point down there. And a reflection is an isometry because we kept the distances the same. And then, Monica, we have a couple of examples of reflections. Because you can reflect things about all sorts of stuff. I can take this and reflect it about the x-axis. And that means I take this point here, slam it into the x-axis, and go the same distance on the other side. I take this point here, slam it into the x-axis, and go the same distance on the other side. Same with this. And I get this. That's a reflection of this triangle about the x-axis. But I can do other weird stuff. I can do a reflection of this about the line y equals x, in which case I'm slamming that point right into there, and then I'm slamming it the same distance there to get someplace around there. I'm taking this and I'm slamming it into the x-axis and going the same distance over there to get to some point around there. I'm slamming this into the x-axis and I'm going again, same distance over there. And then, roughly speaking, that's my reflection of this triangle about the line y equals x. So yeah, I think I was saying the x-axis. I'm slamming all that stuff into the line y equals x. So that's a different type of reflection. All right, Monica, maybe that will help you get through 14.1 and 14.2. Okay, thanks. Talk to you later.